All right. So we want to look at, I want to focus on variables and making sure we can separate between categorical and quantitative. That's what we're going to focus on today. Gallup poll conducted a representative telephone survey of 1,180 American voters during the first quarter of 2007. Among the reported results were the voters' region, northeast, south, etc., age, party affiliation, and whether or not the person had voted in the 2006 midterms. So the first question is who? What are the group of people that we are surveying or interested in? Well, in this case, we're interested in the voters. So the who that we're talking about is 1,180 American voters. That's the people that we're talking about. Variables. So we're just going to make the list. We've got region. We've got age. We've got party. We've got voted in the midterms. Which one's quantitative? Out of those, there are 4 of them there. One of them is quantitative. It's age, right? This one is quantitative. The rest are categorical. Region would be categorical. Party affiliation is categorical. Whether or not they voted in the midterms, that's a yes or no. Those are your categories. You either voted or you didn't. When I say who, it doesn't always have to be a person. Right? We can be interested in studying objects as well. So the who that we're interested in here is Arby's sandwiches. So the sandwich is the thing that we're collecting the data on. And the rest of the things are variables. They're things we're measuring about the sandwich. We'll go through each one this time. Type of meat. That's categorical. Calories. That's quantitative. That's number of calories. And then serving size. That's quantitative. Remember we said yesterday that a clue for quantitative is if you've got units, it's probably quantitative. So the fact that the serving size is in ounces can give you a clue for that. A quarter of them. I gotta look it up for sure, but I believe it's either 0 or 1. Made it all the way. It is actually very difficult to maintain walking in a straight line if you don't have any frame of reference. Mythbusters tested this actually. If you want to look back, they had people walking a straight line, and it's quite funny to watch their path that they think is a straight line, and that it's not.
Like sobriety tests, that's my problem. I can't.
Of course, not on the top right. What am I even doing? All right, quantitative. Handedness. That's categorical. Number of yards that they walk before going out of bounds. That's quantitative. And direction that they went, categorical. All right. Questions on any of that? And we have arrived at the first homework assignment. Remember, I will be posting homework assignments. I said this yesterday, but I'll be posting homework assignments for the day that I give them. I think I said it to the other group. Posting for the day that I give them, as opposed to the day they are due. When are they due? When are your homework assignments due? End of the chapter. And so keep in mind, I'm gonna post this to Canvas today, and it's gonna say it's due today. It's not due today. There's not a submission for it. You can't submit it. It is due. All the assignments you're gonna hand in. All the assignments on. I'm gonna make an assignment that's called Chapter 1 homework, and then you're gonna turn in all your homework from there. Does that make sense? Probably looking at not next Friday, but the Friday after. Most likely. Let's get in the habit of submitting them through Canvas. You can take a picture of multiple files on multiple pages, and I'll be able to see them. New notes. I think we have time. How much time do we have? Oh yeah, we got time. Fantastic. New notes. These are on Canvas. The file's called 1.1 notes blank, I believe. I have more than one page, so I was worried how long it was going to take. So we have categorical and quantitative. So we're going to start by looking at categorical data. And then we're going to, later sections, we're going to look at quantitative data. But we're going to look at how we can analyze it and how we can put some categorical data on a chart. And most of the time, you'll see it in what's called the distribution, the categorical data. So the possible values and how often it takes those values. And so what that means is that you'll usually see a table of, here's the category, here's how often it happened. For example, we're going to start to look at ways that we can organize the data. This is a frequency table. Displays possible values and how often they happened. Usually with a total at the bottom. So, one thing we can do with this table is we can make what's called relative frequency. Relative frequency is basically taking these as a fraction or a decimal of how often these happen. So instead of saying that this happened 10 times, this happened 1 time, just in looking, it's hard to get a sense of, at this table, of how often things happen. But if we start to look at fractions or decimals, then we can start to get a better sense. I may want some decimals out of the calculator from you guys in just a second. But instead of saying that it happened 10 times, we can say it happened 10 times out of 19. And then for DreamWorks, we can say 1 time out of 19. For Disney, 3 times out of 19. Someone get these decimals. And then the rest are 1 out of 19. And then these are all. The idea of these tables, part of the idea is that each of these proportions, if we covered everything, then each of these proportions, if I add them all together, then I should get 1. If I did it correctly. Now, there are a few different ways we can display this data. Let me talk about the ones that you would probably know. Cumulative relative frequency bar charts. Okay, one important thing to talk about is something called the area principle, which is that the area that the display takes up should reflect the count. So, in other words, okay, here's the problem. I don't want these skinnier bars and then all of a sudden have this thicker bar, because then it makes it look like Disney's taking up a bigger chunk than it actually is. And so this is what I don't want. I want to make sure that it reflects the same size as the rest of them. Approximately. So that I can, because the point is to be able to visualize and get a very quick and easy look at how each of the data looks. So that's one way we can do this. We can do this by counts, or we can do this by proportions. So I could do it by like proportion or percentage of each count. And it would look the same, just the y-axis would be oriented differently. Okay? Then we also have, horizontal axis should include variable name. Yep, vertical can be some kind of count or frequency that it happens. Relative frequency, you can compare different proportions and different groups. We'll talk about that later when we actually have different groups to compare. A pie chart. All right, here's an actual pie chart. This is out-of-date data. I think this is from like the first year I did this. Comparing from the whole, don't overlap categories. Label the variable in the categories or have some kind of a key or legend to determine them. And there should be percentages, and this is an even better visual of how they should all add up to 100%. So going forward, what we're going to do when we come back is we're going to look at some displays that are made an error or misleading or something else like that, and we're going to talk about, see if we can figure out what's wrong with the displays. That's what we're going to aim to do when we come back next week. Tomorrow, I'm going to start to introduce some ideas of probability. Yeah, tomorrow, same time, 10:30.